Now that restart data has been requested, let's run the analysis again. Once the analysis is complete, check the work directory. This time you see a restart file, platejobplastic.res. Now we shall set up the restart analysis itself. When performing a restart analysis, the model must be the same as the one used in the original analysis up until the restart location. This means that any geometry, materials, steps, loads, boundary conditions, fields, interactions, and meshes defined in the original model must not be modified. New sets and amplitude curves may be defined in the restart analysis model. New steps may be added, as well as new loads and boundary conditions, which become active after the point of the restart. The original loads and boundary conditions must be active up until the restart. However, they may be deactivated for steps that occur after the restart, as will be done in this example. The easiest way to replicate the model prior to the restart is to copy it. Right-click on Plate Plastic Bending Model and choose Copy Model. We shall name it Plate Springback Model. The new model is added to the model database. Right-click on it and choose Edit Model Attributes. In the Edit Model Attributes window, focus your attention on the Restart tab. This is where we specify the settings for the restart analysis. Check Read Data from Job. Abacus expects you to type in the name of the job exactly as it was spelled in the original model. This, by the way, is the same as the name of the output database file from that job without the .odb extension. Our job was named Plate Job Plastic, hence type it in exactly as that. Abacus gives you a few different options for which point to restart from. You can restart from the end of the step. This is what we will be doing. In fact, since we chose to overwrite restart data from previous increments, and our simulation ran through till the end of the loading step, the only data we have is that at the end of the step. However, you have the option to restart from an increment if you have the required data. In such case, you would have the option to terminate the original step at that increment and begin the newly defined step, or allow Abacus to complete that step from the restart point using new loads and boundary conditions before moving on to the new step. Since we need to type the name of the step exactly as it appears in the original model, we can look it up in the model tree. Now we create our new step, Springback. It too is a static general step. Once again, we set the time period to 1 and the initial increment size to 0.1. We need to remove the load from the plate so that it can spring back and recover its elastic deformation. Right-click on Loads in the model tree and choose Manager to view the load manager. Notice that the concentrated force loads have been propagated to the springback step in this restart model, just as they would by default in a regular model. Click on Propagated and click the Deactivate button. The load is no longer active during the springback step. Click Dismiss to close the Loads Manager. The model is now ready. The final task is to create the job. Let's call it Plate Springback Job and apply it to the Plate Springback model. In the Edit Job window, notice that the job type has been set to Restart by default, since we added the restart settings to the model attributes. Run the job. Let's view the results. Display the Mises stresses on this plate. In a restart analysis, the first frame of the restart is the same as the last frame of the original model. To verify this fact, let's display both of these side by side. In the Viewport menu, click Create to create a new viewport. The viewport is not immediately visible because our current viewport is maximized to fill the available screen real estate. We can display it next to the current viewport using Tile vertically from the Viewport menu. Now you see the two viewports. The new viewport displays the same contents as the old one by default. Click on the title bar of Viewport 1 to make it the active viewport. Then double-click on Output Databases in the results tree. In the Output Database window, navigate to the output database of our original analysis, platejobplastic.odb. Viewport 1 now displays the results of this analysis. A quick way to check to see which output database is displayed, or to change it, is to use the ODB drop-down menu for the visualization module. Note that the ODB file name is also visible in the title block in the viewport. Display the Mises stresses on this plate. Click on the title bar of Viewport 2 to make it the active viewport, and ensure that the ODB displayed is platespringbackjob.odb. Once again, switch back to Viewport 1. Now click the Frame Selector tool. The Frame Selector tool allows you to very quickly display the frame you desire using a slider. Since Viewport 1 is the active viewport, the tool applies to this viewport. We display the last frame of the load step, which happens to be frame 14. Switch to Viewport 2 by clicking on its title bar. Once again, click the Frame Selector tool. This time the tool applies to Viewport 2, since that is the active viewport. We set it to display the first frame, frame 0, of the springback step. Compare the Mises stress contours and their legends in the two viewports. It is evident that the last frame of the original analysis has the exact same stresses as the first frame of the restart analysis. The state block in the viewport also verifies that we are looking at the last frame of load step and the first frame of springback. Switch to Viewport 1. Change the primary variable on the contour to UT, which is translations and rotations, using the Field Output toolbar. Display U3, which is the displacement in the Z direction, which is the direction perpendicular to the planar surface of the plate. Repeat the procedure for Viewport 2. Notice that the displacements are also identical for the last frame of the original analysis and the first frame of the restart analysis. This should convince you that the last frame of the original analysis before the restart point is used as the first frame of the restart analysis, whether this is the end of a step or some increment we tell Abacus to continue from. In this case, we told Abacus to use the last frame of the load step as the restart point, hence the first frame of the restart analysis corresponds to it. It might be of some importance for you to note that the output database of the restart analysis only contains information pertaining to this analysis, and does not contain the information from the original analysis. So when viewing the ODB for the restart analysis, the first frame we see is the first frame of the restart, or the last frame of the original analysis. It is not possible to view frames and field or history outputs for steps that occurred in the original analysis, and you will need to open that ODB file separately in the viewer, as we have done here. As a final note, it is possible to render the plate profile in the same manner that you rendered the beam profiles in the beam frame tutorial. In the Viewport module, choose the View menu to open the ODB Display Options dialog box. In the General tab, under Idealizations, you have options to render beam profiles and shell thicknesses. Check Shell Thickness and click Apply. You will see the shell thickness rendered in the viewport. Note that it was also possible to render the shell thickness before running the simulation. For example, if you are in the Part module, you can go to Part Display Options in the View menu, and if you are in the Assembly module, you can go to Assembly Display Options in the View menu.